Thank you very much, Stacey. Thank you so much. It's a pleasure to be here talking about data management, soil data management, which is something we at ISRIC are doing for a long time. So if you like Teza just said, if you have questions, please raise your hand. Feel free to ask. Feel free to put the questions. I don't mind, and you don't. It's good to have some interaction and to have some questions. So let's move forward. This program today, we will start with some small introduction. I will use some questionnaires so we can also try to engage in some questions, just like the last training. So we'll start by an introduction, talking about ISO 28258, which is a soil standard for data. I'll bring a topic which we think it's quite important about data governance and licensing. Then we'll have a short break, and then the second part, we will talk about data preparation and data cleaning, soil data cleaning and soil data preparation. We'll have a very short uh, hands-on, or I will show how we deal with ETL, how we load, extract, transform, and load. So basically loading the data into the database, and we'll finish with a wrap-up and some discussion. Let me continue. Okay, so last time, a few days ago, Paul gave a really nice presentation as well on the FAIR principles. Today, we will move forward. So basically, we'll go from the FAIR principles into the practice. So Paul touched about FAIR principles, repositories like Zenodo, vocabs. So today we also talk about vocabs, how we will deploy, how we'll make use of these vocabs. OMS, observations, measurements, and samples, data model, and observational data. So today we will see how we can move and implement these in the practice. How can we structure soil data using a standard, a soil data standard? In this particular case, I will, at ISRIC, we use the ISO 28258. Other standards are, for example, Inspire and others, but at ISRIC we deal with the ISO 28258. How we govern license and manage soil data, and how we can clean raw data and ingest it into a database, and then from a database, what we can do after that. So basically, it will be a more practical approach. So I will, before we really go, I have also a Meti. So perhaps I can ask you a question just to engage with you on how you currently store your data. And please I will immediately start saying that there is no right or wrong answers. So it's just, let me just wait. Let me just start with this questionnaire. You can use your cell phone, or you can go to the website and put it here. So let's just start, and please feel free to answer. I'm keen to know how you really store your data. And try to engage on this. Like I said, there is no right or wrong answers here. If you have any issues, please let us know. And you can only answer if you want. You are not forced to answer anything. Let's wait a few seconds and then I will show the answers. Okay, so okay, good. What we see here is just most of you store your soil data in spreadsheets, Excel and CSV. One person already uses a relational database, and yeah, also several ones use a mix of different formats. Yeah, no, I see that no one uses paper records or shape files. Okay, good. Um, in a way, this is kind of expected. And on this training, I will also talk about how we move from spreadsheets to relational databases or other formats as well. So this is kind of common practice, and yeah, good to know. Um, Back to the presentation. Let me just think. In a second, so can something here. Yeah, okay, so it's nice, and I like to see that many of you already uses Excel, and a few already use databases. And one of the key questions is why data management matters. Why do we care about this? Why don't we just store in our Excel and that's it? So, like we just said, like we just realized on these questions, soil data is collected in many different formats by many different organizations. Some store it in paper, some store it in Excel, some store it in a mix of several formats. And without a proper management, without a proper data stays in different silos. And sometimes this becomes unusable, or I don't even know where the data is. I don't know what I can do. What can I do with this data? So oh, data can hmm, data can get lost um, when projects end. So how many? Probably many of you already realize that we have a project, we collect data, and the project finishes, and now what? Where is the data from the project? So this happens in many different projects. Data get lost after the end of the project. Data can also get lost when staff change. Someone left, his data was on his own personal computer, and then data get lost. So these are situations that happen a lot, and I already faced these with many partners. Inconsistent data formats, sometimes interoperability, it's not easy. So we see that many of you, or many of us, we store data in different formats, and then we cannot combine these data sets, or in order to combine them, it's quite difficult. Something that I also realize a lot on, and that's a lot very important, is that there is no clear ownership, no quality control, or unreliable results, and sometimes we don't know what we can do with specific data. So that is why it's very important to have data management, and data management really matters. Um, Something I always say is data management is not IT. It's not an IT problem. It's not a technical problem. So data management is much more than that. It includes the policies, the roles, the responsibilities, the governance of the data. What can I do with this data and how? Okay, so this is why data management really matters. So, and in order to help us, we use standards. I will cover data governance and licensing in the second block. Now, on this, after the introduction, I would like to show you about standards. And standards are important because if we all use the same standard, it's much easier for us to share data. It's more easy not just to share data, but also when we are talking about soil data, if we use a soil data standard, it's much easier for us to talk among each other on soil data because we are using the same terms. So these standards, they tell us on how we should store the data, but they also bring the vocabularies that Paul was mentioning and notions that we always use, and makes it much easier for us to talk about soil data among ourselves. ISO 28258 is one of these standards, like I said before, and like Paul said, it's not the only one, but at ISRIC we make use of it. We use it as well on Soils for Africa and many other projects. So it's an international standard, a worldwide standard for soil data exchange. So basically, this proposes a domain model to store and exchange soil and land observations. And then we'll see what an observation is. This covers observations made on site when you go to a field campaign. And for example, if you collect soil classification or land cover, as well as laboratory results like pH measured in water, organic carbon, etc. This standard is also based on the observations, measurements, and samples. Paul also talked about these last week. And it's basically this standard follows the same approach. Something that I consider quite important and why we use these standards is one of the reasons is to facilitate consistent storage across different observation campaigns and across different institutes and even countries. So we are not forced to share data among ourselves, and we'll see that on the data governance. Although, if we all use the same vocabularies, if we all use the same approach, it makes much easier for us to talk among ourselves and use similar approaches. Why? Because when I talk about what's an observation, we all know what an observation is, what is a measurement, what is a sample. So, and it's good that we all talk about the same language. Something that is quite ISRIC wanted to create implementation of these ISO 28258. So there is a public repository. Let me show you. I mean, it's public. You are free to use it. It's in GitHub. And this is, I'm not going to go into details on this one. So this is ISRIC implementation of the standard. It's public. Anyone can use it. So feel free to read it. There is a lot of documentation. Most of it, I'm going to try to cover it right now in a very resumed way. But if you want to go into details, feel free to go and to read this repository. Second. So what is this standard and what is this data model? So in a very simple approach, um, the data model brings some notions like site, plot, profile, element, and specimen. I'm not going to go into many details, but these are the things that are important. So a site is the geographical location where you take your sample. Then after the site, we have plot and profile. Most of you, in many cases, we just have a profile. So plot is kind of optional. A profile is the pit, or the borehole that we created. So most of the data that I've seen so far, we have a plot, a profile, and a plot. In most of the cases are the same thing. Is where you dig your pit and your borehole. And then we have layers. We can have layers that are defined by the depth interval. So different layers, which we call, and the standard calls them elements. Basically, an element is a layer and an horizon. They can be these two types of things, a layer and an horizons. And then we also have specimens, and specimens is like the physical sample that was shipped to the lab. Yeah, these are kind of the structure, and in a very resumed way, the structure of the data model and the different containers that we have. If there are no questions, I'm gonna tell you what is an observation. So something, and at ISRIC, I'm always repeating the same thing, what an observation is. An observation is always, and I know that we have here a lot of soil experts. So an observation is a property. When I say a property, it can be a property like pH, organic carbon, um, um, whatever. A procedure. So how was this pH? How was this property measured? So, for example, a procedure can be pH measured in water, or, for example, Walkley Black, or many other procedures. So usually it can be the lab procedure. How did you measure this property? And finally, also very important, but I think it's quite easy to understand, is the unit. So is it pH is like, okay, is an acidity unit, so it's unitless. But for example, something can be grams per kilogram, can be percentage. So what is the unit? So when we talk about an observation in the ISO 28258 data model, an observation is these three things: a property, a procedure, and a unit. Always. Of course, sometimes you might not have a specific unit, but the procedure, we might need to have it in a property as well. So it's what we store, what we will store. It's the results that we will store. Do you have questions so far? I know that I run it a bit quick. So if there are no questions, feel free to ask. Yes, Gideon?
Thank you, Louise. I just have a question on ISO standards. I would like to know how ISO standard is being used along open standard. Can you use ISO standards and open standards together? And why the preference for ISO standards?
Good point. So this is an open standard. This the thing is, ISO defined the soil, how the soil data model is defined. So it's a standard, and this is an open standard. So basically, I think this is open. This is a standard why ISO? Because it covers the soil domain. Let me if second if you come to the GitHub, we try to describe. This is an implementation of the domain model, and basically we fold. So many people already struggle on how to store soil data. I don't know if you are aware of the Inspire initiative, so it's quite similar as well. But this ISO is international, so it's not European. Inspire is a European initiative, while the ISO is a worldwide. Uh, and this is a open standard. I don't. Yeah, I understand what you're trying to say, but this is applied to soils. So this is a data model. So this is a standard. So we have standards for everything. We have standards for soil data. We have standards for geospatial data. We have standards for metadata that Paul also mentioned it. This is one of the standards for soil data. So did I answer your question?
The reason I asked is for these specific standard, there is like a paywall in accessing it free. You might have to pay to access it freely.
Ah, yeah. But this is to access the PDF of the ISO. Yeah, I got it. To access the PDF of the ISO, but you pay for you don't pay to use the ISO. The ISO is open, and the implementation we have here is totally open. Feel free to see all these, and if you come to the documentation that we have, um, yeah, this PDF indeed, in order to download the PDF or the paper, there is kind of a payment. But the thing is, the ISO, you don't need to pay any fee to implement the ISO 28258. This is a standard that can be used by anyone, and we don't need to pay absolutely nothing to absolutely no one to use the standard. And if you want to know more about ISO, you can also follow this ISO28258.isric.org. We also described how we implemented, and here you have the implementation and the documentation about the ISO. Yes, Yuri?
It's been very interesting so far. My question is follows like just like you mentioned the metadata. So yeah, there is several ways to store it, several formats, and most of them the complex ones are better. Let's say so for daily drive, most of for data collection we use the spreadsheets, things like that. And so how to organize the metadata in an easy way, or the like the observation, the procedure, the unit. In my understanding, the procedure unit, they are already some kind of metadata. Maybe I'm not correct, but so how yeah, maybe the end of this training we understand that databases are better.
Yes. Good point. I don't confuse metadata, although when we store soil data, of course, we need to store some kind of metadata like the properties, the procedures, and I will show you how to do it. And something that we always advocate is let's use vocabularies. And Paul last week, he was mentioning agrovoc. He was mentioning several. I think I have. So Paul was mentioning different controlled vocabularies. So here we try or we recommend you to follow one of these recommended controlled vocabularies. You can use whatever you want. The thing is, it's important to use vocabs. Otherwise it's complicated. And of course, in the database, and I'm not going to go into I can show you after the training, and probably I can also show you. So we need to store the property, and each time we store a property, we always store a URL that can be whatever. And we recommend that that URL of the property links to a vocab, can be agrovoc, for example. So where you have very well described that property, that procedure, the procedure, you can put the link in order to for the lab procedure. So the units, so all these, we should always use vocabularies. I will go there later. I'm going to touch that point again. But we always need to use vocabularies. I'm always recommending don't create properties, procedures, and units without a proper vocabulary, because if you use a vocabulary and you know that this metadata, how this is described, how a property is described, what kind of property, what kind of procedure. So this is also very important, the procedure. So and for some of you that know me, I already had projects where people share properties, share data, soil data with me, with properties, but without procedures and without units. Without procedures and units, nothing gets ingested. We don't have, I always force and I always advocate for, please make sure that if you have soil data, you always need to have these three things: properties, procedures, and units. Otherwise, it'll be very complicated. Have I answered?
Yes, perfect. Thank you very much.
Thank you. Yeah, like I said, this is the full implementation. It's publicly available. Also, at ISRIC, we created documentation. Feel free to read all this documentation. This can be a massive document. Feel free to use it. Perhaps I can also use here, because these slides, and I see someone asked, we will share the slides with you. So ISO 28258. I'm gonna add here one more website, because then once we share these with you, you can see these documentation as well.
I put them already in the chat, Luis.
Thank you.
But
Thank you.
we'll share the slides as well, so that's perfect.
Exactly. Thank you so much, Thaisa. Yeah, so here you have the implementation, and this is the documentation. So feel free to read it, and later on, if you have questions, we can also discuss it. So the implementation, more questions so far? So moving forward, so we used on this implementation a Postgres database. The ISO is generic. You can use this ISO in whatever type of database management system you prefer. Can be whatever. At ISRIC, we like to use open source tools and open tools. Yeah, I see that Paul just put something very important here in the chat. That it's interesting to understand that this implementation builds on top of the OGC observations and measurements standard. That's why I was always mentioning observation, what an observation is. So yeah, thank you, Paul. Yeah, our implementation follows the Postgres database, and we implemented these on top of a Postgres database. You can download it, you can use it, it's free. License is MIT, you can do whatever you want it with it. And the more people use it, the better, because this is a way to share and to store soil data, and so it's an implementation of the standard. Basically, this implementation has all the documentation, diagrams, database migrations. This is something that is evolving. This is not fixed. If you have issues, you can create issues, etc. We can continue. We are continuing making it better and better. And this has been used in multiple projects. For example, Soils for Africa. So this standard And this implementation was the backbone of Soils for Africa data, but also many other projects that we at ISRIC are using. Even WOSIS, I don't know if you are aware of it. Is a product that we have at ISRIC, and WOSIS also is now based on this ISO 28258. Okay, so I'm not going to talk much more about ISO in theory. I'm just going to move forward for the next part, which is data governance and licensing, which I think is quite important. But before that, so if you have more questions about ISO, theoretical ISO, please let me know. When we'll come back to the ISO during the presentation, because I will show how you will clean the data according to the ISO. I will show how to load data using ETL into the ISO. So the ISO is the backbone of how we store soil data. So if you have any question, otherwise we can move forward and talk about data governance.
Feel free to ask. You can also drop them in the chat. I see Paul and Ulan also reacting there, but yeah.
And something that I think is quite important is these standards, they kind of align, because, for example, when we say that this is the open implementation of the soil ISO 28258, this is not just pure ISO. It's like Paul mentioned very well, we made these in a way that aligns to the observations and measurements of OGC. So these things are aligned. And if you know Inspire initiative, this is not too far away from the Inspire initiative. So these standards, in a way, we need to make, and we can implement them in a way that it's easier for us to move from one standard to the other. And what's the purpose of having standards is make sure that we all talk the same language, because then what the property is for one institute can be totally different from a different institute. And then we are talking about a language that we cannot understand. So ISO makes sure that we all talk the same language. A property in ISO is always a property. In observation is always a set of a property, procedure, and unit. So we are always talking the same thing. Moving forward, so standards are important. How we implement and how we store data is important. But now I want also to bring to the table something that I consider perhaps as much as important as the way you store the data. And perhaps even more important is data governance and data licensing. Because, so what is data governance? Why do we need it? So basically, before we start with storing the data, dealing and cleaning the data, harmonizing the data, serving the data, there is several questions we need to ask. And like, what is the framework of rules, roles, and responsibilities for managing the data? Who is responsible for doing what? Who owns the data? Who can access it? Who is responsible for cleaning and for the quality of the data? So who decides what gets published? In many cases, when we share data, we don't share the whole data set. We don't share everything. We just share a part of the data. Or we can share the whole thing. So who decides what to be shared and what not to be shared? Who is the real owner of the data? Who can access it? And who is responsible for the different components of the data? And this is a question I think is really important. And before we really start with the Excel files, etc., I think it's very important to define the data governance. So again, data governance is not just an IT problem. It's actually, this requires agreement across the organizations, the different teams, and even at some point, different countries. If we have a project that works like IUSO that has different countries. But so it's very important to have this agreement. What can be done with the data? What is the data governance? Why does IUSO need data governance? For me, this is quite clear. So IUSO collects data from multiple countries and multiple institutions. So without governance, who decides what gets published? Who decides what to store and how? Who decides who is the owner? So these are the key questions for the different stakeholders. Who validates data quality before the publication? Who is accountable when the data is incorrect? If something is incorrect, who is responsible for fixing it? How we handle conflict data from different sources. Imagine that you have data from different sources and they are conflicting. Who needs to sort that? Can partner countries maintain control of their own data? Yes or no? So these are the whole questions that we can argue and we can talk about data governance. So basically, the governance is a framework, and this framework makes sure that the data is trustworthy, that the data is clean across the project in this IUSO project. But this is a topic that is important not just for IUSO. This is a topic that is important for all institutes. At ISRIC, we have different projects. We always have a data management plan where we decide the first thing is the data governance. What can be done with this data? Who are the responsibles for this data? Who is the owner? If we are going to share data, how are we going to share it? So all these are the different topics that are really, really important. And sometimes I say that this is as important as storing the data, or even more important than storing the data. So I don't want you to fall asleep. So let's have one more question at Meti. Let me share the Meti. So feel free to join the Meti, and let's ask the question I'm going to ask you. You just answer if you want, is in your organization, who decides which soil data gets shared publicly? Is it an individual researcher or a data collector? Is it your project manager or department head? Is it a dedicated data governance committee? Is it the ministry or your institute or the agency? Or is nobody? It's just there is no formal process. I'm really keen to hear what you like. Once again, there is no right answer. All answers are valid. The idea here is just to engage with the discussion with you.
Yes, Luis, I know that in many African countries, there is no clarity on this. And if we give a chance to the countries, they can say as much. But I know that there's no clarity on who makes the decision.
Yeah, it's not just African countries. From my experiences worldwide, in all kinds of not just in soil. So this is a topic that is relevant, of course, in Africa, in Europe, or in everywhere. Everywhere I worked before, and I've been working in Latin America, in Africa, in the Middle East, in Europe. I face always the same struggle. So that's why it's quite of important to give this awareness. And I think things are improving. I hope so. And yeah, and thank you very much for your insight. Okay, so let's see the responses. Hmm, quite fair, eh? So I see that, yeah, in most of the cases, we have a department head or project manager. Okay, at least someone that decides. I also see that many of you already have nobody. This is expected in a way. So, but this is where perhaps we need to have some action. Department head, good. Individual researcher or data collector, okay. And dedicated data governance committee, good, good. Yeah, so like I said, there is no right or wrong answer here. What for me is the most important thing is we need to understand that data governance is really important, and we need to understand the importance of the data governance. Any comment from anyone else? Anyone else wants to comment these results?
In countries that are low resourced, let's say they don't have the wherewithal to implement data governance, maybe they don't have adequate staff for such, how can we provide a solution for that?
Very good question. Thank you very much. I really like it. We don't need to have a committee. I mean, it's good to have. It depends on the case. Depends on the use case. Something that I think it's very important to decide this data governance. It should be kind of a fit to purpose. What's the purpose of your data? What is the purpose of why are you storing data? What do you want to do with it? Is it at the institutional level? Is it at the governmental level? Is it at just for your at the university, the department level? So depending on what you do with your own data, so you don't need to have a very complex mechanism of data governance. That's why I was saying the only thing that I don't like much is this nobody. Although I can understand, but all the others are okay. Sometimes the department head or a project manager is enough. So what is important, what I think is important, is that these questions are answered, like who owns the data, what the data can be done, what can be done with the data. So as long as we have clear answers to who are the responsibles for the data, what can be done. So as long as these can be answered, then it's fine. And it's fine if it's just a project manager. It's fine if you don't need to have an expensive project committee that needs to gather every month or so to discuss these topics. No, what we just need is to spend some hours with someone that is the responsible, and that responsible can be the responsible for the project, can be sometimes can be even a full professor that is responsible for a scientific paper, So as long what is important is that we have clear answers to the questions of the data governance. So who validates, who is the owner, who validates the data quality, who is accountable for the data, what can be done with the data. So, and these, I think, are the most important questions. And at least someone needs to answer them. Who? Then it depends on the institute. And you don't need to, so that there is no need for expensive and complex solutions here. Sometimes just one person, the response, because if you have data, someone had to collect the data. Someone needs to be the responsible. And sometimes this can be very easy to answer. Have I answered this question?
Yes, thank you, Luis. You've answered.
Thank you. Sometimes these is topics that I really like, and I'm working a lot for many years on these, and sometimes I might talk too much because this is really something that drives me. So now some subtopic that is quite important is what about data licensing? When we define the data governance, it's very important as well to define data licensing. So data licensing is especially, and I'm bringing this topic now under AUSO, especially because when you share data publicly, not just publicly, when we share data with others, publicly or not publicly, or depending on how you share the data, it's very, very important when we to define a data license. I could stay here the whole day talking about data license and the legal regarding it. I'm just gonna give it a very light topic about it, but data governance and data licensing are always side by side. When we decide the governance of the data, we should also decide on, and the person responsible for the data, we should always decide the licensing. And this is something you do in the beginning. Once we define a license for our data, we should not change it. And this is very important, especially when we share data with others. I bring here just 4 types of licensing, but there are many, many, many others. These are perhaps the most well-known. So which is CC BY, so open. So licensing defines the terms of use. This is very important. When we define licensing, we define what others can do, or what we can do, or what can be done with the data. Licensing never defines ownership, and it cannot change the ownership. The owner of the data is always the owner of the data, okay? Your data always remains yours, point. Licensing just tells others what you can do with the data. So CC BY is perhaps is the most open. So anyone can use the data, share it, and adapt your data. But of course, they need to say who is the owner, of course. The ownership does not change. CC BY share alike. In a way, I like that as well. So derived products must use the same licensing. So basically, if you share CC BY SEA, so it means that if others use your data and they produce something else, a derived product, that derived product must also use the same license. So needs also to be open. So then you also have non-commercial. So basically you can share data and say, this is only for non-commercial applications. And of course, the last one is restricted, case by case. So access is granted, within specifics. So it's restricted, and the owner of the data just shares data depending on the other on specific conditions. Which I tend to avoid going to the restricted unless really necessary, because if I publish data publicly, then it's always good to define one of these 3 licenses. But of course, restricted is also a possibility. Why do we need data licensing? Well, basically your data, your ownership, licensing just defines how others can use it. Without licensing, there is no rules. So without licensing, I think the biggest problem is if you don't have a licensing, nobody knows what they can do or what they cannot do with your data. So it's not a very good practice to put unlicensed. I have here some questions which I'm not going to ask you to answer these questions. These are just questions to raise the awareness and for us to just to think about it. Okay, so some of the key questions that we need to have when deciding data licensing are: can I USO redistribute data, or can I redistribute the data that I shared? I put here the IUSO, but can be done in many other projects. Can be done on your institutional level. This is not only for IUSO. Think about it for the different scopes, different projects, different ways of use to share data. So can I redistribute the data? Can others redistribute it? Can third parties use it for research? What about for commercial use? Can companies use it? What attribution is required? By attribution is, if I use your data, how do I say how I do the attributes of this data? How can I say this data belongs to person A or for institute B? How should the attribution and how should I phrase on how is the owners of this data? So, and something is very, very important is a clear licensing from the start avoids problems in the future, avoids disputes later. That's why I also say we should always define, when we define the data governance, we should always define a clear licensing. I don't mind whatever license you choose. It's okay as long as you choose one and you stick to it. You should never change the license later, because then that can also create problems. So let's go to the next question that I have here. So I just have one open question and there is no right answer. So just a situation. Imagine that you have a governmental funded national soil survey in your institute, and a private company wants to use it commercially. Which license fits better? So let me open, go to the next question. Yeah. Feel free to answer it. So imagine that you have a national survey that was funded by the government, and now you have one public license, public company that wants to use the license. we can wait a bit more time. So feel free to, if you want to answer, feel free to answer it. Let's see the responses. Okay. So the one that should not be selected, I see that no one selected it, which is good. Yeah, I mean, if you have a governmental fund national survey, and if a company wants to use it, first it depends on the owner to know, to allow that to happen or not. Okay, so, and then of course you can choose open attribution, CC BY, and which is one of it's possible. So basically this is public data, and then you can, anyone can share it alike as long as they do the attribution. CC by SCA, it's also a possibility, although I know many companies don't like it much, but it's also a possibility. Basically, you are saying that private company can use the data, but any product that they do it commercially or not commercial, so even a commercial product, it also needs to use share alike, needs to be shared just the same way. Non-commercial use, I see no one selected it. I think it makes sense because if it's a private company, so it must be a commercial. So, and the question says it's a private company that wants to use it commercially. So non-commercial cannot be used because otherwise you are saying that you cannot use it. And then restricted access. I see that many people also select restricted access. Can be. Although I don't like much these type of restricted access, but can be. So basically, you are sharing the data with the private company, and you have one agreement only for that private company. So which means that if another private company or if another agency comes to you, it's case by case. Just make sure that this restricted can give you a bit more work because it's case by case, different cases, different scenarios, and you need to be able to justify at least the data government needs to be able to justify why you have case by case, which can be. I'm not saying it cannot. Good. Anyone wants to comment? Questions?
The only reason I opted for the restricted access is probably the dataset contains personally identifiable information, then you have to restrict access. But if it doesn't contain PII, then you can use CC BY, which they can use for any purpose.
Absolutely, absolutely. And like I said, this is like the restricted access is a possibility. And of course, if you have data that it has information that you want to share, but you are keen and you want to make sure you have case by case scenarios, then restricted access can work. Absolutely. There is just one thing that just one comment to your comment, which I think is really important, is sometimes we need to share the whole, or because we are forced, or because someone asked, the whole data set. But just sharing a part of it is also a possibility. So, for example, I can use at ISRIC WOSIS. We have a public version, which is the biggest part. We have open data that is totally public. And in WOSIS, you have CC BY, and you can download using CC BY. But there is another part, a part of the data is not publicly available. So, and we do not share it. So the part that we share and is publicly available, a part of the data can be publicly available using one license. So, and another part of the data can be just restricted access. This is also a possibility. So when you say, I'm going to use this license for you don't need to say this is the license that I'm going to use for all the data sets, all the data that I have in my institute. No, different data sets, different parts of the data can have different licenses. And this is also a possibility. More questions? Yeah, so just trying to finish before we go into a break, how does these pieces fit together? Data management, like what I'm trying to say until now with these slides is data management is not just one thing. Basically, data management is standards, is governance, is licensing. I also put it here, is the cleaning, harmonization. So when we talk about data management, we don't talk just about IT people or technical people or soil data or just governance. So data management is composed by all these 3-4 pillars. So basically, in this particular case, in the case of AUSO and in the case of ISRIC, ISO gives us the data model. We already discussed it. Governance gives us the rules for who does what. Licenses gives us the legal frameworks for sharing. And used together, we make soil data trustworthy, reusable, interoperable, and clear, with clear rules. So without one of these, the system breaks down. So if I don't use standards and I have licensing, governance, then the system is much more difficult to be interoperable because we will be talking different things. If I don't have governance, I don't know who is responsible for what, and the same with license. So I always need to have these 3 things all together, and this is quite important. Before we go to a small break and for more questions, I had just here a scenario that for you to think and just to bring and raise the awareness. No, you don't need to answer now. Just think about it. Imagine that a country collected data, soil data, with public funding. A university wants access for research. A private company wants a commercial product. So you see that we have a public data, a public funding that created data, and then different people, different stakeholders want to use this data for different purposes. A university for research, private company for commercial product. The questions is, what governance structure would you set up? Who should decide the access? Which license can you apply? And would the license be different for the university or the private company? So these are all questions. I have my own answers, but what I want to tell you is, depending on the use case, depending on the country, depending on the institutes, these questions are important to answer, but there are no one answer to fit them all. So these are things that it's important when you have a project like AUSO and like soil data and data in general. It's important to think about these possibilities and these questions. Myself, I like a lot of open data that can be open for private companies and universities, etc., as long as they keep the attribution. But depending on the use case, depending on the data, depending on on many things, the answer can be different. What is important is to think about the questions. Anyone wants to react? Anyone has a question? So if there is no question so far, I would suggest if there is also, and you all agree, we can have a short break, 15 minutes, and then we'll continue.
Yeah, sounds good, Luis. And let's then come back in 15 minutes. And then in the meanwhile, if you have any questions, feel free to still drop them in the chat, and then we will answer them after that as quickly as possible.
Mhm.
Alrighty, guys.
Thank you so much.
Thanks.
Yeah, let's move forward now. If there are any questions, please feel free to ask. It's all good. So now on this part, we are gonna actually we are gonna talk about data preparation and cleaning, of course, against the standard that we are gonna use it, but we are preparing and cleaning the data. Then I'll show it very, very rough on how we usually upload the data, and then we close it with a wrap-up. So the next step is basically from raw data into ISO. Something, and thanks for answering the Metimeter question. And one of the first question I asked was, how do you usually store the data? And I've seen different formats, Postgres databases, but also Excel. So basically now what we want to do is move this data that you have from raw data into the standard. And you'll see that it's not as complicated as it may seem, although there are key things that we need to look at. So basically, what we need to map. So when we have an Excel file, basically what we need to do now is understand what are the fixtures of interest. What are we observing? And the fixtures of interest are what I had here in one of the previous slides about ISO are these ones: site, plot, or profile, and layers and specimens. What do we have in our data? These are the fixtures of interest. Sites, profiles, layers, and specimens. Then what are the properties? What are we measuring? Is it pH? Is it laboratory data? Is it spectral data? That's another topic that I have not covered here, but it follows the same principle. So what are we measuring? Procedures. How was it measured? Wet chemistry, spectroscopy, like I was mentioning before, and the units. What is the units? How do you store the data? Is it percentages, gram per kilogram, whatever? And then on this presentation, I want to highlight several common problems that we face. So missing or wrong coordinates, this is very common, and I faced it very often. No clear separation between profiles and layers. Although in most of the data sets that I've seen so far, this is probably the less problematic one, because most of the cases, this separation is quite evident. Inconsistent property names, this happens a lot between data sets. So something that we have a lot, and I face it, I have different data sets, and the properties are not consistent. And that's why it's very important to have this vocabulary, so the property is consistent all the time. Missing procedures, that's something I don't have here, but it happens and it's really problematic. When we have laboratory data, we must have a procedure. If we don't have a procedure, I cannot ingest this data into the standard because I might have pH, but I don't know how this data was measured. pH measured in what? And if I don't know the procedure, then I cannot compare the data. And so procedures are very important. And depth intervals so if I don't have depth, that's also problematic. So now when we have raw data, we need to align these or harmonize it or standardize it, because in this case, we can use the word standardize it. Why? Because we are standardizing our data against a standard. What is the standard? ISO 28258. So in this case, we can use standardization. So basically, we need to look at our data and try to have the different concepts. A project, on the standard and on this database type, I can have multiple projects. The project is the top level, the hierarchy, the most high level on the database. And in the ISO, we have the concept of project, which is good because imagine an institute where you have different data sets. This means that you can have different projects and sub-projects. We can have IUSO, and under IUSO, we can have different sub-projects. So projects and sub-projects are possible. So we can have the project, a campaign, or a survey of collected data, a site where the data was collected, and think, why do we have site? Because imagine that we can have a site, a location that has been revisited over time, and the site is always the same. But of course, then I will create different pits over time on the same site. That's why we have this notion of site. Then, of course, we have a profile, a pit or a borehole. Then we have elements, which are layers and horizons, which are defined by the upper and lower depth. Okay. Well, these we are all, you are soil scientists, so you don't know it better than myself. Then we have specimens, so a physical sample that was taken from a specific layer, but yeah, I'm not going to go too much. Because a specimen, we need to have the depth in which was taken. And the observation. Okay, so we have the features of interest, site, profile, layers, specimen, and you have the observation. And the observation is a triple of properties, procedure, and unit. So what we need to do is when you have data, if you have, for example, an Excel file, we need to map the different columns that you may have into these concepts, okay? And this is basically the most complex task, the data cleaning part of it. Questions so far? So moving forward.
No,
Yes, Daisy?
No, just checking in as well. If we go too fast, please let us know as well.
Yes.
Or if the pace is okay, because Luis is happy to stop somewhere and explain again if needed. No sign is a good sign, we assume.
Yes.
So, I think Luis, you're still.
Yes, Gideon.
Oh,
Yes,
Gideon.
please.
For the site, what's the recommended option?
No.
Are we to use coordinates, or we have to use the exact location where the experiment was gotten
Coordinates.
from? Coordinates.
I'm going to show, site, because in this standard, I understand that the site sometimes is a bit, not everyone understands the notion of site, because profile is mandatory as well, and profile is quite clear what a profile is, at least profiles and layers. I think these are many people has the location on the profile. Although the standard makes a clear distinction between them. So site is just location. Basically, site is a site can be a point, a pair of coordinates, lat longe, or can also be a polygon. So the site stores just the location point. And then we have the different profiles, which are connected to a site. Because imagine that a site can be a point, but also can be a form or a polygon in which you take different profiles. So a site can be a bit of several things, but the site is basically the location. If there are no more questions, vocabs. So now, vocabs are extremely important here, and we already had a question about the metadata, where we store this type of metadata. We can think about it kind of a type of metadata, although with so these vocabs are important in properties, procedures, units, extremely important. Paul already introduced the control vocabs, and these are very important because here they connect. When I create, and I'm going to assume, and when, for example, if you use the database that ISRIC provided in GitHub, we already have many different vocabs and many different properties, procedures, and units, which we used from AgroVoxam and also from different vocabs repositories. So these properties is what we observe: pH, organic carbon, clay, and it's important to have these linked to one of the vocabs. If you want, I can show you this in the database because perhaps it's easier for you to see. The properties. So what is a property? pH, organic carbon, etc. Procedures. So pH measured in water, Walkley back, pipette method, the different procedures, and the units. Okay. In this implementation of the standard, each of these parameters must be linked always to a control vocab. The properties, the procedures, and the units. Why? Because if I link this to a control vocab, then I will ensure interoperabilities across different data sets and countries. Okay. And then when I share data, if I share part of the data or some data, then I can tell anyone or even my colleagues what is this property and how this was measured in a very clear manner. Let me show you. Perhaps if I show, this becomes more clear. I'm going to show you a few tables. Don't get scared, because this is, for example, I'm going to show you an observation is a property, property, physical-chemical properties, and let me show, yeah. Okay, so in this, also something we use, one of the control vocabs we use, are we also using the glosses code lists. And these are properties, okay? So I just need to store the property name and a URL, and of course the database has its own IDs, which I'm not going to talk about. But for example, we were talking about pH. pH or potassium, nitrogen total, for example. So all these properties, these are just all the properties, aluminium. So if I copy these, and I show you here, here we have that control vocab. I'm using glosses. You can use whatever. So you can use already the existing ones. We can adapt it. We can put agrovoc. So it doesn't matter as long as it's a URI from a specific place. You can also use your own internal documentation, reports, etc. So here I have, so each time I have that specific property, I know this is how this is being described. And of course, for soil scientists, and this should be clear, okay? Same, and the very same from procedures. Let me show you procedures. So let me show pH measured in, you see, pH measured in water with different ratios, okay? I'm gonna copy them. So what is important is we don't need to reinvent the wheel because these vocabs already exist. Let's make use of it. So these are the different, so soil pH measured in water in a 1-to-1 soil water solution. You see, so these are the procedures. The same for units. So if you use the database model that we have, and it's publicly available, anyone can use it. The license is MIT, which means that it's totally open. It already comes filled with the glosses vocabs. Units, units of measure, the same principle, you see. Now I don't have it's just the label, percentage, for example, and here I'm using a different vocab, but that's all good as long as you use one. It's the most important. The most important is to use one. Which one? I don't care. So this is percentage. Here it is how it is described, and yeah, that's it. You can also use agrovoc, for example. You can use whatever makes sense. Your own internal documentation. That's it, basically. Let me share it. So why these vocabs are important? Exactly for interoperability. And for the future, I know exactly what I'm measuring, how am I measuring, and the units that I'm using. This is very important. Okay, moving forward. Are there any questions about the vocabs and the properties, procedures, and units?
Yes, Louis.
Yes.
As AUSO, we would want to also decide on one vocabulary. One more. What would be the guidelines for choosing one from another?
What? Sorry?
What would be the guidelines for choosing one from another or from others?
What is important is to choose the vocabularies, the vocabs. And under IUSO, I know, of course, we need to choose the vocabs. As long as we use one, it's fine. As long as we define the vocabularies, then it's fine. What we need is to define them. So the guidelines to which one to use or how are we going to define the vocabs, I will leave this to the soil scientists. And what is very important is to have one and to say, okay, this property, we are measuring these properties, which are defined on these reports or on these URLs, etc. These procedures And for example, I know that you can use, for example, the different lab procedures, but as long as they are defined is what it matters. How we define them, then I leave these to the soil scientists, I leave these to the different persons, the different labs, etc., the ones who take the decision. What is important is to say these we used these procedures, these properties, these units. That's all it takes. Then how we define them or which vocabs we are going to use, I leave this is defined when we do the campaigns, when we do for the different owners of the data, when we create the data. We have the field protocols. So on the field protocols, we also can have different vocabs. So as long this should be defined, and then once it's defined, it's what I want to know, because different campaigns, different projects, they will have different purposes, they will have different characteristics that and there is not one vocab that fits them all. So when we go to a campaign, when we define the project, then we need to define the different vocabs, and that's all totally okay. Did I answer the question? What is important is to know which one to use.
Yes, you answered it. Well, I know that we would like to encourage countries within Africa to use a standard vocabulary that AUSO would be using. But from your experience, what would be your recommendation?
I'm not gonna, I mean, we use a lot of glosses, for example, in Source for Africa. I'm gonna use the example of Source for Africa, okay? So the vocabs that we used was agrovoc and glosses, mainly. So in Source for Africa, those were the vocabs, and glosses and agrovoc, they were enough to fit most of the vocabs that we used. Of course, in units, I used the one that I showed, the quote, and that's it basically. I'll start with agrovoc, with glosses and agrovoc, but this also depends on the countries, depends on the different stakeholders. So I think it's very important for us to respect the decision of the countries and to respect the decision based on, because no one better than you to know what are your needs and what do you need. Usually I start with existing ones, like the ones that Paul mentioned, agrovoc, glosses, etc., and then start from there.
And also, no single vocabulary contains all the variables you might need. For example, agrovoc might not contain some geographic coordinates. So it has to be like a mix of various vocabularies for you to use. You can use agrovoc and many other vocabularies.
Yeah, good point. Exactly. Which is okay. Which is okay. For example, in South for Africa, that's why I was saying in South for Africa, I use mainly glosses, but I also use part of it agrovoc, and it's okay. So when I just show you the database, I'm just using the plain database that when you download the database from the Git repository, this is what you get, is you get an empty database already pre-filled with some parameters. And this is, when you go to the Git repository, feel free to explore it. When you deploy it, this is the database that you get. So that's what I was just showing it. It's pre-filled with something, but it needs adjustments. Check.
And
Yeah.
Luis, how that is the same Git repository that you shared earlier?
Absolutely. Yes. This is the same Git repository that I shared before. It is actually, let me show you. It is, let me share the link. It's this one. This one here.
Yeah.
Okay. So the link is on the slides. And actually it's in GitHub. So if you go to ISRIC World Soil GitHub, if you search for, you'll find it. Of course, I'm not gonna exactly say how you launch it internally. So your database administrator looking at these, you just need to follow the steps that are here. Basically, it's 4 steps, and you have a database in a Postgres. But I'm not gonna. The goal of this presentation is not to teach how to install Postgres and how to launch it. But yeah, just follow the documentation and everything is there. You also have a plain on the releases. We have a plain SQL that you can just dump into your Postgres database, and this will work. I'm not gonna go with too much technical details here because this can be too much.
Yeah.
But yeah.
But if there's a need for that later on, then we can, of course, always.
Absolutely. And this is totally public.
Yeah.
The same because this is the database according to the standard. And of course, this is you can test it. And of course, if you have more questions, we can answer later on.
Thanks, Luis.
You're welcome. More questions? Okay, so cleaning part. Okay, we already checked. So what we need to map on our Excel or CSVs, whatever, what are the different properties, procedures, and units, and also project site profile elements. We need to know this, which in most of the cases you know. But now we need to clean it. By cleaning is identify common issues, identify things that might create problems on the database. For example, geometry, okay? And this is something that happens a lot. And this cannot be, it needs to be you, needs to be the persons who knows their own data to fix. This is the best approach. I cannot fix your data for you because no one better than the responsible for the data, and this is important to identify on the data governance, who is the responsible for cleaning the data. Remember, we talked about that before. So it's important to identify the key persons during the different steps. So there are people who really know what they collected, who really know that data set. So in the majority of the cases, these soil experts are the best to fix this data because they know the details of the data. So validate coordinates. So it's important for us to understand, hey, okay, I have a pair of coordinates, but these coordinates they need to be valid, right? So usually we can use QGIS or any software to plot these into a GIS platform and then see if they are okay or not. Removing valid geometries. Imagine that if you miss a latitude parameter, if you are using latitudes that don't exist, this plot cannot be plotted because you don't know the coordinates, you don't know the location. So it's important to really know the coordinates, and these are geometry checks. Then we also have profiles. So it's very important, and I think this is most of you. From my experience, most of the soil experts know this rule. If we have layers, if we have measured layers, even a topsoil is just one layer. if we have layers, it's important to know which profile links to which layer. So I cannot have orphan layers. I cannot have a layer that does not have a profile. Otherwise, I mean, I can, but then of course these won't go to the database because it's an orphanate. Good question, Gabriel. When must the data be clean before importing in the database or when already in the database? My recommendation is before you ingest it. And I'm going to talk about ETL after we clean it. So my recommendation, clean the data before you ingest it to the database. Why? Because the database already have rules. And otherwise, you are just storing data with errors, and it will be much, much more difficult to clean the data after you ingested it. So my recommendation, if you have Excel files, if you have, and you are uploading it to the database, check it before you do the ingest, always, because then the ingest will be much more clean. You can, before you do that, you can assess with your colleagues. So it's always better to do it before importing to the database. And that's the assumption that I'm having now. So before I do the ingest, before I send the data to the database, I do a cleaning. I check for these common issues. I look at the data and I check about for these. Identify profiles and layers. What is a profile? What are the layers? Usually I put it in separate tables. Depth. So I think this is quite obvious. Upper depth and lower depth are required, and upper depth needs to be higher than the lower depth. Okay, so I cannot have layers without depths. Okay, so I always need to have an upper depth and a lower depth, always. And if I don't know, I either remove it or I fix it. So because on this type of errors, because if you run the ETL, you ingest it into the database, those values that are they will not go inside the database because you have a layer without depths. So I should not have duplicated records. I need to identify all the properties, procedures, and units. We already talked about it. It's important to understand that some properties can be unitless, and that's totally okay. Like, for example, pH, root presence, yes or no, or depending on the classes. So I can also have classes like land cover, for example, and in this case I don't have units. Okay, but I need to have a property and a procedure and some. Something that is happening also a lot are dates. So usually is better that careful with the dates because we should always have the same date format and it should be consistent. Why? Because otherwise, if I mix different formats, sometimes I don't know, I might have a wrong date, So, and this is quite easy. Believe me, it's quite easy to change the format and mix different formats, and then I don't know which date that is. And worse, when you import it to the database, you get a wrong date, and we don't want wrong data in our database, correct? So these are kind of, I'm not going to go into all the little details, but these are mostly the common issues. And now I'm going to share a small exercise or a small exercise with different questions also to engage with you on different errors that we might have. But before that, more questions? Anyone wants to react? Think about your own data.
For examples, what you run into? we're more than happy to hear anything.
Yuri?
No questions. Everything is fine. Thank you.
Thank you. Okay. If no one wants to react, let's move forward. So then let's go for a small exercise. I'm not gonna ask too much. So just imagine this table and this small data set. And this is a real example I had in the past. Actually, it's more or less, I modified a little bit. Can you just look at this sample data set? It's just with 5 rows. Can you spot the issues? Can you spot any issue here? Perhaps we can go to the Metimeter and the same Metimeter and look for the issues. There are lots of issues here. I'm not going to cover them for the moment. We will discuss them. Give me a second. Yeah. So anyone, Gideon, do you want anyone wants to react? Let me.
From the table.
From this table, yes. Yes, the issues are on this table. And now on the Metimeter, the idea is to find the issues and or other comments. Let me check if I have here the Metimeter. Give me a second. So the Metimeter is here. Wait, I think I just made a mistake here. Wait. Yes. So basically, you can now, I think it's now okay if you want to. Yeah, go ahead to the Metimeter. So I have several questions on that sample data set. I'm gonna hide it and share the table so you can see it. For the first question is, in this data set, which columns identify the location of a site? Just look at the database. You have 2 options, lat long, top centimeter, bottom centimeters, pH water, and procedure.
And that's the lat long.
Wait, don't say anything yet. Yeah.
Okay.
Yeah, so of course, so let's look. Yeah, everyone selected lat long, and indeed this is the lat long. Of course. So which columns define an element? A layer, top, bottom, lat long, pH, or procedure? I think these ones are quite easy. Okay, so let's see the responses. And yeah, everyone, top and bottom, because a layer is defined by the different depths. Now, okay, a bit more difficult. What is pH H2O, water, pH water, in ISO 2858 terms? For the ones who knows me it's what I'm always repeating myself. I'm always saying the same at ISRIC. Okay, so can I move forward? Yeah, okay, good. So it's an observation, because why? I understand it's an this pH water, that column represents an observation. So this column represents an observation. Okay. Why? Because it's pH, the property. The procedure is measured in water. And the unit in this case is unitless, or you can also use unitless the pH values. I understand the ones who selected vocab. I understand, because indeed an observation is composed of property, procedure, and unit, and we need to use vocabs to define property, procedure, and unit. Vocabs are important on the observations because vocabs define the different properties, procedures, and units. Its use is useful to use vocabs when we define the observations. But that column represents an observation. So it's good that when we look at our Excel files, we know that, for example, this is an observation. This is also an observation. This is just a procedure, okay? Yeah, the correct answer was the observation. Okay, so next question. Which data quality issues can you spot in the data set? Okay, let me show you. So I think you have the METI also on the chat. Thais also shared the METI link. So you can see the sample that we have here. So which quality issues can you spot here? And then we can talk a little bit about these quality issues. Something I recommend is check, think about your data, think about your own problems. So we can now discuss a little bit about this because I think there's a lot that can be said here. See, 8 persons responded. We can wait a few more minutes, a few more seconds, and then. You can also think about questions, because now after we can use these as a good starting point for questions and different things that we can discuss. So okay, so let's move forward. Yeah, okay. The correct answer is all of them. So we have all these issues on our data set. I think most of you answered the correct way. So all of these are issues. Let's look at the data. So for example, I have missing values of latitude and longitude here. Okay, this I don't know the look. Sorry, I don't know the location of 002A. Okay, but this is also a problem, and this I already saw it multiple times. So nuns and something that is nothing there are the same thing, but we need to validate. So on these particular cases, they cannot be ingested to the database because they don't have location. And in this case, one of the main principles of the ISO is that for each profile, you must have a location, you must have a site. And if you don't know the location, then what I would recommend is just remove it from here if you don't know, or go to the report and try to find it out. Like this, what will happen is if you try to upload it to the database, either it's not going to upload absolutely nothing, or it will generate an error, and then you need to fix it. And why do I prefer to fix it right now? Because imagine that if you put this in one ETL, they will either give an error or these lines, they won't be uploaded. And then it means that you might think, oh, but I just uploaded the data to the database. Yeah, but it has an error, so you don't have it there. So fix it before. Something I also have it, and this happens a lot. So pH values with values greater than 15 or negative values, these are all outside the admissible bounds. So it's not possible to have pH of 15. Sometimes what happens is sometimes in the field or when we were copying the data, or there was a step somewhere, perhaps a point was put in the wrong place, a comma was put in the wrong place, someone made a mistake. So this is good to verify these values before you ingest it, because sometimes the fix is easy. Perhaps it was not 15.2, perhaps it was 1.5, although I find it strange if it's 1.5. Still, could be something like that. But it's important to go to the source data, to your registry, and make sure. And then, again, the data governance, the person responsible for the data needs to decide, either I remove this line, either I remove this measurement. I don't need to remove the whole line. That's a good point. For this case, either I fix the value or I just remove it. And having nothing there is also fine, okay? Because then I don't have a result, and it's fine. The other thing is I have latitude, we already discussed, latitude empty or latitude none. These are different issues. So they need to be addressed because none means nothing. So nothing or not having nothing there is pretty much the same thing. So they need to be fixed. So yeah, in this case, I had text in a numeric column. I should check what are the data types, numeric, text, etc. The other one is the procedure is missing. So for all the results, for example, for each one of these pH, whatever, for all the results, I always need to have a procedure. Sometimes I don't have a procedure like this. I don't need it. You need to map it on, for example, here, pH water is the procedure. So organic carbon, what is the procedure? So you need to know what is the procedure. I just put it here this on purpose to say missing procedures are not an option. And this happens a lot. I already faced a lot that I know the property, I know the unit, but I don't know the procedure. So for all these cases, please check and make sure that you know your procedures. And then the other two, upper depth and lower depth. So if I have something like this, be careful. And sometimes even worse, the upper depth makes no sense, or is sometimes upper depth negative layers. I know the litter layers, like leaves in forests. These sometimes can happen, but be careful because to understand if it's really an error or if it's a real value. But like this, it cannot be. It's the same. Upper depth and bottom depth are the same. So be careful with that. And we always need to have values. And the last one, which is also very critical, are the dates. And let me just edit this because the dates are very important. Careful with the data format. If I have different date formats, this can be problematic because the ETL cannot ingest it. And imagine why can this be problematic? Because imagine this. If I use something like this, you see, this can be problematic. Is this 24 of day 24 of month 3 of year 2017? Or you see, because date formats, they can be mislead to error. So it's very important that we define how the date format was set exactly to avoid, because if I have different data formats, date formats, then you can be lead to errors at that. And then once you ingest this into the database, believe me, you will never fix it later. So these are things that are quite important. Yes, Yuri.
Just a quick question here. So let's say to map in a static file, let's say CSV, is it improper to map the procedure as a procedure and unit as secondary or tertiary header? I know it will mess up with the data ingestion, and it's not a good, perfect solution. But later these lines can be skipped or cleaned, or
Absolutely.
just extract as just a header as a metadata or something like that.
Yeah, absolutely. And actually, this is a very good question. I'm going to show this then on the ETL, I'm going to show it. For example, when we do the ETL, then we are going to say this column represents top the upper depth. This column represents lower depth. This column represents this observation, which was already set by a procedure property and unit. Same with this one. And this one, I don't put nothing. This can be just for my internal, I can put it on the CSV, I can have it, but I can just keep it and don't map it on the ETL. So the script will ignore this column, and that's okay. So not all the columns, they need to be mapped. And then I'll show you later on. So on the ETL, you can just say, these are the columns, and these are the columns that you don't put, he will ignore it, okay? And you can even have an Excel file with multiple auxiliary tables. You just need to map the right ones. Usually I like to work with CSVs when I'm doing this type of things, because it's quite, usually I use, that's one possibility. I use 2 or 3 CSVs, one for properties, one for layers, and that's it. And then I set a configuration saying, on this CSV, this column represents this, and that column represents that. And that's it. And then he goes and fetches from these columns the right values and puts it on the right place. That's the ETL. And I'm gonna show it a little bit to you. I'm not gonna go into details on the ETL because this could be too much. But of course, we are here. We can help you with that. And of course, this can be an open door, and then we can communicate and have more discussions in the future. More questions? Okay, let me continue.
Any question is allowed, eh? We're happy to answer anything.
Absolutely. And there are no bad questions. Everything is allowed. Believe me, I've seen many things, and even myself, even today, I have lots of questions, and sometimes I need to come to talk to my my colleagues, soil experts, soil scientists, also to explain many things. So it's okay to have questions.
No.
Okay, if no, we can continue. Yeah, these are the types of issues that are very common. I just try to put them the most common ones. But we can have a lot of problems. But these are the most, these type of issues are what you can find out there. Okay, so we can now continue. And now I'm gonna just try to talk about ETL. What does ETL mean? Do we have people that already deal with ETL?
Yes.
Okay. Anyone else already using it as well? You can also put a heart as reaction.
So ETL stands for extract, transform, and load. So extract is extract the data from where you have it. Read the data from a CSV, go to a report and then extract it, check where is your data. So this is the most, or probably the most easy, and you don't need much complexity, although sometimes you need. But check where you have your raw data, extract your raw data, okay? Then you need to transform it. So by transform is what we were doing. Basically, we were doing the transform part. Map the different columns, clean it, standardize it against the ISO, know what is a site, what is a profile, what is a layer, what are the different observations. That's the transform part. Basically identifying the different components and, if needed, putting everything in the CSV. Slightly transform the CSV to be able to ingest it. And then the load, which is the most easy part, which is basically run a software program, and we at ISRIC we have one. Run a software program that uploads the data to the database. Once the data is on the database, then it will be you can use it and link it to the different softwares, dashboards, OGC services, etc. But the most difficult part is this transform and data cleaning. At ISRIC, we have one, is not yet public. This ETL is not yet public. We are working to try to make it public. So, of course, we if needed, we are still working on it. I'm going to show you the load part. And of course, we can if you need something similar, you can contact us, Thaisa, and then we can show it to you how we do this software to us. Within time in the future, I think we will open it. But just don't forget that this ETL is just the load part. There are no magical solutions to the clean part. So the clean and this part of the check the errors, there are no software solutions. Of course, now with LLMs, now with scripts, we can automate a part of it, but there are no magical solutions. So you need to know your own data in order to make it clean and ready to be standardized. Okay, so
if you allow me a quick, sorry, if you allow me a quick question here, maybe it sounds a dumb question, but
no,
when I get data from somebody else, I never touch the raw data because maybe there is something wrong, but it's not an outlier. So I always try to keep the raw data, and then I do a second version, but sometimes I do it more painfully through the scripts than doing it manually, because then I know exactly what was changed and when and why.
Yes, I understand your pain. I feel it. Yes. So usually that's why we are trying to clean the data together with the partner when possible. Other times, when we do scripts, we always have the same script to fix the data. So the thing is, I don't fix data. I don't fix data. Either if the data has errors, it does not go to the database, and I just generate a report saying, for this profile, these layers were ignored because the pH value, for example. Let me show you here. Okay, so for what happens here is if I have a script, the script will not fix data. If I have like something like these nuns and missing values, then these lines won't be added because I don't know the location. If I have mixed dates, I ask someone to please tell me what are the correct data formats. Otherwise, I pick one data format. Otherwise, probably data formats can be even more problematic. And for example, if that value here is missing, I don't add it. In this particular case, 15.2, I don't add it. It's outside admissible bounds. I'm not responsible for the data. Then I don't have enough insights to know if this was a comma put it on the wrong place or whatever. So I'm not going to fix data. I don't fix it. So what happens, I generate always a report and the data does not go. And of course, then I talk to the partner. So my recommendation is, if you use a script, make sure that your script is reproducible and always generates the same output. The same input always generates the same output, because then you can reproduce the error. You can assess it together with the partner. At the moment we try to fix data that does not belong to us, I think it goes against the data governance and can create problems. Because then we don't know, we might be adding errors to the database, and then the owner can check and say, no, but I did not share this with you, and it was not correct. Look, I faced this already. So that's why I don't try to fix data, because unless if I really know what happened. Did I answer your question?
Yes, perfect. I never see on this perspective. And recently I worked with a large database, and there was some missing data, but I was collaborating with the partner, and we just came in agreement for interpolation inside of the profile using some tools, something like that. And it works nice, but I have a final question. So if one layer is missing, I think the whole profile or the profile information is also kind of strange. So in this case, you consider to maybe remove, or I don't know, flag the whole profile.
No, yeah. Well, if one layer is missing, you can add the profile. But again, it depends. Again, go to the data governance part. Who is responsible for cleaning the data, and what are the different responsibilities? So if we have, it's okay to have a profile without layers. That's totally okay, because at least you know that something was measured on that place on that specific date. So it's the same like this one. This one here, in this case, is different. We might have a layer which, in this particular case, pH will not be added, and organic carbon will not be added. And of course, the layer won't be added in this particular case, because you don't have everything is wrong on the upper depth, lower depth, and the observational results are also wrong. So you won't have it. But on other cases, you might add the layer, because perhaps the layer has a legal and okay value of pH, but does not have organic carbon, and that's okay. So you just add a result, you create a layer, you add results on it. So if you have a profile without layers, that can be okay. That is also valid. But again, it depends on the data, because perhaps you add a profile but no values of layers, then perhaps you doesn't add anything to the data. So yeah, that's why it's always good to know who is the responsible for cleaning the data, because that person knows the context and knows the different responsibilities, and he's the best person to know this makes sense and this does not make sense. Now you understand why data governance is so important. Because if I'm going to clean your own data set, probably I don't have enough information on the different insights to do it in the best way possible and take these decisions. What makes sense to remove, what makes sense to keep.
Perfect. Thank you very much.
You're welcome. Anyone wants to react? Okay, moving further. Okay, so for example, when we do the loading, when we do the ETL, like I said already, each measurement column becomes one observation. So in here, in this table, I have two measurement columns. I have two observations, okay? These two. And these are very important to map. I need to know for each one of these observations, the property, the procedure, and the unit, and of course the different vocabs that define them. And the ETL, even if you use one ETL that was already generated, or if you create your own ETL script, they need to know what are the different properties, procedures, and units. because this can even complicate even more. I can have pH measured in water, and the procedure, this is the procedure. I can also have spectroscopy, and in this case, I can have pH measured in water. And the method also needs to be, and the procedure needs to be described as spectroscopy as well. So that's why it's so important to the procedure. The procedure is really important, and already happened to me a lot not having procedures. So if you don't have it, before you ingest the data, you need to understand what is the procedure. And one more thing, identifier and location columns map to site, profile, and element or layer. So these are not observations. So for example, lat long, date, upper depth, lower depth, these are identifiers of the site, profile, and layers. And we map them, we need to configure them, but these are not observations. I can show you a little bit of detail on more or less how we do it at ISRIC. But this is an open, this is open, so you don't need to use exactly the same way we do it. The most important is make sure you map and you know all these different columns, observations, and then you can use your own scripts, or you can use a tool like this one that we have at ISRIC. There are other ETL softwares out there, so anything can work as long as you know and these procedure cleaning steps and the different mapping to the different components of the standard. Let me show you. Yeah, at ISRIC we have kind of an ETL, which is, I'm just going to show you the interface and how we usually do it. For example, this is kind of an ETL, and then we can, of course, different, most of you might, we will try to open it, but this is more or less how we do it. We create a CSVs, and then we define the connection to the database, and then we define 3 CSV files. Usually we try to do this transform in-house, a field, and the soil chemistry. So like the field data, profiles, and layers. This happens quite often. We have a profile and the layers CSV, 2 tables. In most of the cases, that's what happens. Then I need to browse the files and put them here. So like the layers and the profiles. Optionally, we can have a spectral data. So imagine that if you have spectral derived data, then you can also load it here, another CSV. And then it comes the most important part. The configuration. So it's the mapping part. So we can have different projects. And then you see, we need to define to say, on my CSV, so imagine these columns that I had here. On this CSV, what does it represent latitude? What does represent longitude on the site? In this case, latitude is set by lat, longitude, I need to check, lon. Altitude, I don't have altitude. In this case, I can just remove it. That's enough, okay? Latitude and longitude are mandatory, altitude is optional. And now I come to the plots or profiles. Now, plot code, you see, in this case, I have here, I just have a sample ID. Of course, then in plots, I need to have the plot code, and I'll put plot ID. Timestamp, it was date, you see, date is correct. This one I don't have. Slope, I don't have slopes, because sometimes in the plot you can have slopes. Sometimes I also can have individuals, so person who was the surveyor. So I could have it here. I could have a column with the surveyor name, like surveyor name. I don't have it in this case, but I could have. Here I have the same lat and lon. And then something that I can also have for each for the different profiles, in this case, plot and profile is the same. I can have results. By results is observations. And I can have 3 types of observations always. So text, free text, descriptive, or numeric, you see. And this is where we put the observations. In this particular case, I don't have, but I could have land cover. You know, so if I have land cover, could be a column with land cover, then I could put it here, land cover. Could be a text or a descriptive. I'm not going to go much more details. For example, or soil class, for example, classes, for sure. And this is a good a topic I wanted to bring. When we do soil classification, in many cases, we store this information not in the layer, but in the profile. And then, of course, we need to say, you see, what is the soil class? Because imagine that you have one column with the soil class. What type of class? Is it FAO? Wait, this is closes and the link is broken, but it's fine. So you see, yeah, I could have different soil classifications, and this is important to have the URI of the vocabulary. Can be glosses, can be agrovoc, etc., defining what type of classification. FAO, WRB, the year, etc. So that's why one line defining the soil classification, and then you put the different classes. Then, of course, the same for layers. You see that this is kind of generic. Upper depth, so it's top centimeter and bottom centimeter. Top centimeter, bottom centimeter. Sample ID column, in this case was sample ID, it's correct. Code, sometimes I can have a layer with a code, other times this is optional. Organization and lab, so if you know the name of the laboratory, you can also put it here. If you have a column with that, you can map it here. And then, for example, I just have here some physicochemical example. A layer can also have text classes, but the most general are the physicochemical. And if you see, for example, I have here some examples, pH measured in water, property, procedure, and unit. You see, these are the ones that you probably already have it. So you need to put here the property, procedure, and unit. And this is the column, pH in this case. I'm gonna remove it. So remove this, you see, because I just have pH measured in water. And then I can add one more, which was organic carbon PCT, because this is the column of the CSV, and this is the URI where you have the procedure, property, and unit. And then I will need to put it here, and the system automatically grabs this value here and puts it on the right place on the ETL, on the database. If I had spectral derived results, the same thing. So basically, these are just the configuration. It's just a configuration. Once you are okay with it, we can say to append the data to the existing database. So I can continue adding data, or I can delete the whole project data and add it again. So I have these both options. Okay, now I don't have it here. And then run the ETL, and what the ETL this script just does, it copies the CSV values and puts it on the database. That's it. And then a database is, I'm just showing you one database example. The database is here with the different layers, etc. All these ETL, all these ISO, and I can show you, for example, SOS for Africa, which follows the same standard. Okay, observations measured. I can even show you the observation, the properties, physical-chemical. These are different properties that we have. But more easy, all these databases, all the implementation that we've made, it allows us to create things that these views with all the data. Once you upload it, then you can visualize the data. You can connect to dashboards, you can connect to OGC services, etc., depending on your needs, on the project needs. But it's very important to be able to map the different fixed errors, clean the data, and map the different components of your data. And then you can use a tool like this one, or a script that you created, or any other tool to run, to upload the data and to run the ETL. In this case, I call it ETL, but it's just the L part. This script only does the loading part. The extract and the transform is always your responsibility, because the system will not clean and they will not check for error. It will check for errors, but if you have errors, you just have a report saying this could not be ingested, and that's it. So the idea, any question so far?
I have a quick question.
Yes.
I like this loading or ETL interface. It looks very nice. But I think is there another option like to do it via coding? Because
Absolutely.
I suppose here there is some copying and paste, and I try to avoid that.
Absolutely. Very good question. I do it all the time with scripting, and I can show you. Actually, I can show you. Very good question. Give me a second. Let me share the other screen. Yeah. I mean, that's why eventually we want to open this code publicly. We are having some discussions internally about it. So this is just a front end. What I just showed is just a front end. That front end is just the tip of the iceberg, and there is a Python script, actually, which I say it here. Basically, this is a Python script, and you can run it as a batch, and you can run it UV. I'm using UV. I don't know if we have developers here that know Python. I use UV. You can use just a front end, and you don't need to worry with nothing about just copy, click. But the front end calls a command line, and this command line is a bulk, and it's just a script that runs like this, and you can run it. You can put loops. It runs. It needs to have your username, password, host, etc. Takes as an argument your CSV files, and takes as an argument the configuration file. Sometimes the configuration file is just a JSON file. Let me show you. Let me show you. Config. I have the config. Config example. This is just an example. I mean, this is coding. Most of you will be scared. Other ones will love it, like me. So basically, we just say, what's the column name? I'm just showing you in code what I did here on this configuration. Okay, I'm just saying each field, what does it represent? latitude is here, longitude is here. Actually, this interface, you can create the configuration here, download edited config file. You can download it. And this is just this JSON. Or you can do it via coding, and then you don't call the UI interface, you just call the scripting interface. Why is this important, the scripting interface? Because something that we used, for example, in Soils for Africa, no one is there uploading new data all the time. What we do is we connect this script, this very same script, to a Git CI/CD. Now I'm talking technical. Stop me if I'm going too technical now.
Heading there, Luis, but you can finish your sentence.
We connect this to GitLab or GitHub Actions CI/CD. Each time new data comes, we have a trigger action that calls this ETL script and loads the new data automatically to the database without human intervention. You need to have very good control in the middle, but this can also happen. And the script, the software is exactly, the ETL is exactly the same. You just don't use the front end.
Oh, that's very nice. Thank you very much for showing the let's say under the hood.
Under the hood, yeah. This is exactly. I hope we can soon open this also to the public. We are just discussing how to do it. But you see, so basically these are just configurations that you run, and then of course all documented, and then I see. That's it. But for example, load multiple projects. You see, so we can load automatically multiple projects, etc. The front end is just to show, to help the users that are not familiar with programming skills, so they can just use the front end, or help users to create the configuration file the first time.
Perfect. No, it's very, very useful. Thank you.
Thank you. More questions?
Well, maybe in the plain language, Luis. So what it does is that if you collect data in the field, it automatically can transform, load, and upload it in a soil database. So that is basically what this is in very plain language.
Absolutely.
And what Luis just showed on the back end, that is how this was created, but this front end is already available that anyone can use for their own as well.
It's not yet public.
Oh, not yet.
It's not yet public. We are I mean, for me, I could do it publicly today. I have no problems with that. We are just internally, again, the governance part at ISRIC, we are discussing the governance part. If we should, on how the persons who are responsible on how to make this available and what is the license, etc. But of course, if someone needs to use it, I mean, of course, we can show you, and you can test it.
Yeah, and this is also how we worked under Soils for Africa in the data
Absolutely.
that came in, and we will work in a similar way for AUSO as well. And this can then, of course, also be applied on a national level scale if that is required. This is how we'll do it for AUSO.
We are already using the very same components also for national level scale. For example, in Ghana, I know Ghana people are here, so you know. Also for Ethiopia and others. So we are also using this internally. More questions?
Yes, Luis, I know that you're saying it's not yet public, but maybe we can customize it for AUSO.
Absolutely.
If possible, even in Java, if not Python.
Well, in IUSO, no, for IUSO we can use such a tool. Of course, probably we need to see if needs adjustments or not. But yeah, absolutely. So the idea is exactly with all the partners, we are sharing this with most of the partners. So it's totally okay. It's not publicly available, but we are already using it for many projects, and for sure in IUSO, that's what we will use for sure.
Yeah, I guess it also has some lines for detecting quality issues and flagging them off for human interventions.
Generic ones, yes. Basically, what we have is data that are outside admissible values will be skipped. But of course, when we are cleaning data, everything can happen. Everything can happen. So that's why I always like people, okay, let's look at the data first before running it. Because yeah, imagine that if you write in the date in date format, I can write two different dates in the same date in different date formats, and they mean totally different things. So, and then there is no way any script, any tool can detect it. So yeah, many things can be detected automatically. Other ones can just be bypassed. So yeah, that's why there's although, for example, in Soils for Africa, the data we have a good pipeline, and the data there is no human intervention anymore to load the data at this step, and most of the errors we have very small errors that go to the database. So, but still we need to assess it.
And maybe also to add on that, that is of course important because garbage in is garbage out. So if errors enter into the database, that will then also be used for the mapping part, which I think Luis is coming into now. So it is really important to minimize the amount of errors that goes into the database itself.
Absolutely. Thank you, Thaisa. And this is a really important topic because, I mean, we can try to do the best tools ever, the best AI ever, but if we don't know what we are cleaning, errors will eventually end up in the database. And I'm always saying in a funny way, don't put garbage in our database, because eventually garbage in the database will propagate to the products. And in this slide that I now have, when you connect, because the database is not the ultimate goal. Actually, the database is just the beginning. Why we want a clean, standardized database? Huh? Why do we want it? Exactly. That's the next slide. To make this data accessible via services, to make this data viewable for maps, for dashboards. And if your data has errors, your maps, your dashboards will also have errors. And then the insights, imagine soil quality, soil monitorization systems, will also have errors. And believe me, once you have errors in the database, and these errors propagate so fast, no one realizes. And we might be giving wrong advices to the different policymakers because these errors propagate, and then they are very difficult to find. So the right place to fix them is right in the beginning. Yeah, more questions?
No, I had just one remark to Christian remark actually about this. And I was thinking that just to explain, in work package 3 in this project IUSO, what it will do gap analysis and try to find out data sets that are available at national partners, at 12 national partners that we can use, and also identify data that should be collected in a project. But those 12 national partners will collect the data that they're willing to share. And that somehow has to go through this process into this database. And that's where we need probably to identify with each national partners the person that is knowledgeable about this data, able to do first exploratory analysis of its own data and to find out what are the issues with the data. And together we can then start putting harmonizing data in a single database, probably. That's just for future remark.
Thanks, Sulan. More questions, comments, remarks? So, like I was saying, the result is not the ultimate goal. So after this, we have accessible soil data. Once the data is in a standardized database, it becomes accessible via OGC services. You can connect any map server, geo server, whatever tool you use to the database. You can connect dashboards, map viewers, QGIS, ArcGIS, whatever. So it's queryable, is downloadable, is interoperable, and this is important because, like I said, you connect different systems to the same database, and you can have different insights. Like also Theresa was mentioning, ready to be used for soil mapping, digital soil modeling, decision making, etc. So clean and well-managed data actually can be turned into good insights, into a good infrastructure that others can use. Always don't forget that we are not just doing this to make data public. That's not the goal. The goal of this is to create good standards. So we also can create dashboards, insights, analyze the data, create maps, also for internal use. Because if we have just CSVs, it's much more difficult to share these CSVs with different partners because we always need, if you want to visualize the CSV in a QGIS or ArcGIS, you need to transform the CSV into a shapefile. Then you have a CSV and a shapefile. Then if you want to have a dashboard, you need to create, how do you do it? You create, either you connect. So there are multiple ways, and then you end up with scattered data, many different files across different computers, and that can be problematic. One single database, clean and harmonized, means one single source of truth. So that populates, so the different insights are always drinking from the same clean and standard place. Yeah, so moving the next block, that's what I wanted to say. So this is the full pipeline. Each step depends on the one before it, and then if we skip one, we will break. But eventually we can end up with publication. I just put publication, but publication, insights, maps, etc. So governance, licensing, then standards, which one? Data cleaning, and then ETL, loading the data. And then we can create different publications or creating maps, insights. Then we can use, in the last part, basically, we can turn data into policies. You can use the data, basically. Questions, remarks so far? We are reaching the end, I think.
I have a question, but I think you can reply it at the end about, this is coming from a perspective of somebody that never used or used very little database. Because, CSV, they are static, they don't go wrong, just text file. Should we do backups on the database, or should we export everything in a static format once in a while? But feel free to respond it at the end.
I don't know to respond. I don't know the answer. Depends. The answer is it depends. Depends on how you have your infrastructure, depends on your policies, etc. Because if you, for example, depends on how you do your data. I don't like much the idea of having multiple files in multiple computers. Of course, backups are extremely important, but when we do backups, we should have a strategy, a backup strategy. A little bit like the governance and licensing of the data, we also should have backup strategy, which means like, when do we do backups? Which folders, which files, where are the backups stored? Do you also do the backup of the backup? Seems redundant, but it's might not be that redundant, because perhaps you want to do two backups. For example, on the backup strategy, what is the recurrence? Do you do daily backups on a weekly basis, and then you store 1 week, 1 month? For how long? How long are the backups being stored? So all these So I could have one training only for backup strategy. So what I think is important is to have a good backup strategy. Of course, when we have databases, also when we hire the database, when we set a database, we also need to have a good backup strategy. When we go, if you hire a backup, a Postgres database in any data provider, they already provide as well a backup strategy. So it's good to be aware of this backup strategy. And it depends on your needs. It depends on the services, depends on the infrastructure. It will depend.
Yeah.
Fulan?
Yeah, I just want to add a couple of words to this. I think it's a good question, Yuri. And I'm trying here to connect these two trainings together. I remember training by Paul, giving, maybe you were not there, but Paul was giving training on about fair data, but also about repositories. Repository is a good way to actually store the original, your field campaign. Your field campaign will be A, B, C, D, and maybe it makes sense to store this raw data, annotated metadata in the repository. It's long term, it's preserved, it's there. Then you can, next stage, you go through this data cleaning process of harmonization and storing in a database more dynamic data that you clean, that you do all kind of performance operation. You can still dump the version of this database version labeled certain dates and times and store in a repository, but that's a way of kind of combining these two trainings together and giving you a data management pipeline. I think ideally that would be the situation for us. And ideally, we'd be able to connect to both the database of your organization and maybe raw data that's collected in a repository with metadata in it, so that we can do on the raw data or on your database. In principle, I'm just saying the other users as well. But this is the ideal situation. So ideally, your organization, any National Soil Institute or IUSO should have both data repository containing the raw data, field data campaign, CSVs that are labeled, surveyors, and etc. And slowly you want to harmonize all of this data and combine in a single database, because one more function probably that Luis mentioned, what database serves is not only this, but it's also kind of a knowledge of the organization, long-term knowledge. It does not depend on people leaving the organization and taking their CSV as shape files with them. You're lost. But database is a place where it's kept. In a repository, it's the same place. So these are two long-term preservation of data as well. That's a function it carries.
Very nice. Thank you very much, both of you.
You're welcome. Actually, just one reaction to what Ulan was saying. So these public repositories can also be used, quite useful. Just be aware that if you use, for example, Zenodo, the metadata will always be available, publicly available. Of course, the data can be private, but if you put your data in Zenodo, the metadata, so the data owner, what is this data about, etc., is always public. But of course, in many cases, it's really useful. And for example, I can imagine cases where you want to upload and keep data reports, PDFs. Imagine that the data was legacy data was created with, I'm just giving one example that already happened. We have lots of reports, PDFs, and all the data is there. Then we converted that data to CSV. And then these PDFs are in Zenodo. We put them in Zenodo, they're publicly available or not, or just the metadata saying that this PDF exists, belongs to person A and B, and it has these contents. If you need, please contact us. And then, of course, in the link, in the property procedures and units, in the procedures, we put the URL of these reports, because it was reports from the 50s, So this is also a possibility. So that's why I'm saying depends on the data, depends on what we are doing. Different approaches are possible, and there is no one that is better than the other. No, it depends. And thank you very much, Yuri, for your question. I think also for the others.
Thank you also.
More questions? Then I have one. last question for Matti, and I'm gonna invite you to join Matti and ask this question. What is the first thing you'll improve in your current soil data management? This is open-ended. The idea is to have kind of cloud of words. Try to be concise, like 1 or 2 or 3 words. Try to put it in a small, if possible, just 1 word. That would be great. Let me. It's here. Let me wait. Just. Yeah. Feel free to respond.
In the meantime, somebody, Francis, asked
Indeed.
something in the chat.
Indeed. I'm just reading. Francis, good question. Aside Postgres, which relational database you can use, which already takes in consideration the ISO? So from what I know, we only deployed this in Postgres. I don't know others. I'm not aware of it. There was an idea to create this into GeoPackage, but and SQLite, but I'm not sure it has been implemented yet. For example, if you have MariaDB or something like that, it will also work, because we try to make it as generic as possible. But basically, if you want to do it, you can adapt it to any database type, any relational database, MariaDB, MySQL, Oracle Spatial, Microsoft DB, whatever, it will work probably. But we implemented in Postgres because it's open source and it's one of the most advanced database management systems out there. Yeah, I hope I have answered. I know that also exists some converters, so you can also create a Postgres database and convert it to any other database. So the possibility exists. Shall we wait a little bit more, or shall we see the results? Let's wait. People are still writing. Let me put 1 more minute, and then we see the results. So basically, at ISRIC, we try to use as much open source as possible, because then anyone can copy it and see the code, and then you can apply the same to, we can apply this in multiple projects. Yeah, that's our policy: open data, open formats, and open source tools. That's why we deploy this in Postgres, and yeah, I think it's a good strategy. Okay. Let's see the results then. What you'll improve? Yeah, I see lots of people work governance, the word governance. Setup database, yeah. Data standardization, cleaning, I think. Metadata, data gathering. a very good one, informing colleagues, like communication. Communication is quite important, and that's one of the goal of having the whole thing is interoperability. Interoperability is communication, using vocabs, data cleaning, of course, data governance a lot. Digitize field reports, yes, good. Using standards, check my data on errors, yes. It's important to check errors, because if you don't do it yourself, if you don't check your data for errors, no one will do it for you. And the ones that will do it, probably it will do it worse than yourself. Infrastructure, very good one. Implement a database, set up a database, yes. Data standardization, yes. Okay, very good. I like it. I think we will keep these cloud word clouds. I think it's quite nice.
Yeah, it's lovely.
Anyone wants to react? Anyone wants to say something? Okay, so
I wanted to say I think we know the topic of next training. It's in big letters there.
yes, indeed. And perhaps more important, I mean, I love to set up databases, and setting up the database is important. Cleaning your data, ingesting your data is important. But perhaps more important than all that is come up with a good governance framework. Governance is important. It's a waste of money and resources. Create a database if we don't have a good strategy, a good governance framework. Otherwise, we are just spending time, effort, and lots of money, and for something that we don't know how to govern and we don't know how to maintain in the future. So I'm happy to see that data governance, it's informing colleagues is also it's here. And vocabs, I mean, all that is good. So I just have some open discussions, just for you to think, and after you close this training, just at least you have some questions for you to think and to discuss with your colleagues, and how these apply to your country soil data, what challenges you might see adopting these standards, what could be your first steps. And yeah, and think on what support you'll need from IUSO. Yeah, just think about it. You don't need to answer right now. Just think that these are just discussions to think and to start discussion on the next months. And thank you so much. And if you still want to continue on the meeting, so I'm going to leave this open, and for at least the next week, these will be suggestions for improvements or the topics. This questionnaire will be open for the next days. So feel free to add something. If you don't like the presentation, you can always say it here. If you like it, you can always say it. Improvements, whatever, feel free to add. And thank you so much. Yeah, Yuri, I see. Can you recommend a hands-on training course in Postgres database implementation? Yes, I have something that if you want to know a lot, let's wrap up, and then I can answer your question.
Yeah, thanks everyone. Thanks, Luis, for joining. Feel free to fill in the Menti, because it also helps us to define the next training topic. So if you say, well, I want to know more about governance or anything else, or do let us know. We are planning during this whole project timeline to give more trainings in order that we can inform everybody on the different topics that are relevant. So do fill in the Menti or reach out to us. We're more than happy to answer anything. Are there any, except for you, Luis comes back to it, any questions or remarks or anything? I heard somebody on mute, but oh. Jacques, yes, please come in.
Thank you very much. I'm very happy to join the group and the training. I have a small intervention to do, but I want to do it in French, and I ask Richard to help me to do the translate in English. I don't know if is possible or not.
Richard, otherwise, Louise, I don't know how your French is. Not existing.
Really bad.
Jacques, otherwise, you can type it in the chat. My French is half, but if I see it in writing, then I understand it better. If that's okay for you.
Okay, I do it.
Yeah, then I
Okay.
can answer it.
Thank you for your help.
Maybe, Louise, while we wait for Jacques' question, you can already answer Yuri's question.
Yeah, perhaps. Yeah, go ahead.
But thanks everybody for joining. We will stay here to answer Jacques and Yuri's questions. But thanks everybody for joining today, and major thanks, Louise, for organizing and hosting.
Thank you very much. It was a pleasure. So hope to see you. Thank you for being here until the end. Hope to see you again in the future.
Thank you very much.
And Yuri, I'm writing to you here and to others. So if you want to know more about Postgres, depends on your knowledge. Probably you can start with a plain SQL tutorial, which I'm putting here, then a basic Postgres tutorial, and then after that, then you can go to PostGIS for GIS components. I mean, I like has a basic start. W3 schools have some open tutorials which are quite interesting, basic, very basic. And then from there you can go to more advanced things.
I appreciate. I will go through this
I'll
resources.
start with SQL, just do the tutorial on SQL, then Postgres, because Postgres implements SQL. If you know SQL, you know, then Postgres, and then from there you can continue.
Thank you.